Hi, good day viewers. Welcome to Science Spectrum with Don. You're welcome to the second broadcast of Chemistry Classic. And that's the continuation of the first broadcast in Stoichiometry. And that's balancing of chemical equations. So in today's class, I would treat more on balancing of chemical equations. Stay tuned. Alright, now I have an equation. Say I have an equation like so. Solid, liquid, solid, liquid. Alright, so this, the term on the left side, that's the reactants. These are the reactants. These are how 1 on 1. This is the term on the left. And of course I have the terms on the right, that's the products. And these are the terms on the right. So how do I balance this up? Clearly I have to make sure that the amounts of elements I find on the left side, that's the atoms, has to correspond with that on the right side. Alright, so solution, pretty straightforward. I have the terms on the left, that's my reactants, and I have the terms on the right, that's my products. Then I'll list out the elements, okay, on both sides as they correspond. So I find aluminium on the left, is also on the right. Then I could have taken oxygen, okay, alongside aluminium, but oxygen came out twice on both sides, so this should come last. The same with hydrogen, came out twice here, but came out once. So this hydrogen and oxygen should come later. Now I go to sulfur, so I could see sulfur on the left and on the right, and it came out once. Then hydrogen follows after with oxygen. Alright. So all I need to do is to make sure that the number of atoms of these elements are the same on both sides. So aluminium, to start with, there is a 1 here, subscript of 1, and there is a number at the back which we call the coefficients. So this subscript of 1 times 1 at the back, 1 times 1 makes it 1 on the left. And on the right, the subscript is 2 here, you have 2 at the subscripts, and 1 at this coefficient. So that's 2 times 1 makes it a 2 on the right side, that's for this aluminium. Then we go to sulfur. Sulfur is 1 times 1. So it's 1 on the left, and on the right is 1 times 3, this is a subscript, it affects both elements. So 1 times 3 is 3, then the 3 times the 1 at the back, coefficient, that's the 3 for sulfur. Then we go to hydrogen, there is a 1 here, times 3 is 3, then 1 at the back, that's 3. So 1 times 3 times 1 is a 3. So we have 3 hydrogens on this side, but still we have 2 subscripts of hydrogen here, so we have 1. That's 2 atoms of 3 times 1 at the back, the number of moles. So this is a 3 plus 2, that makes it a 5. So we have 5 hydrogens on the left, and on the right is just a 2 we have. Then we go to oxygen. 1 times 3 times 1 is 3, then it also appeared here. So 4 times 1 is a 4. So 3 plus 4, that makes oxygen 7 on the left. And on the right, we find 4 times 3 is a 12. 12 times 1 is still 12. Then 1 times 1, so this is 13. We have 13 oxygen right here. If I'm not mistaken, let's see. This is 4 times 3 is 12. 12 times 1 is 12. Yeah, so it's 13. So I have to make sure that these numbers are the same, both on the left and on the right. So starting off with aluminium, aluminium is 1 on the left, 2 on the right, so I have to make it 2 on the left. So I would stick in the coefficients and the number at the back where I find aluminium. So clearly, I could stick in the 2 right here. So 1 times 2 now makes aluminium a 2, equal 1, right? Now, I go to sulfur, but before I do this, right? Before I do this, let's see. Okay, now I go to sulfur. Sulfur, I have to make it, this is 3 on the right, 1 on the left. So I have to make sulfur 3, 3. So I will stick in the coefficient where I find sulfur. That's it, coefficient of 3, since it's 1 to start with. So 1 times 3 makes sulfur, or 3. Right? Okay? Now, clearly, what I've done now, right, affects oxygen, the same with hydrogen, because I stuck in the granite at the back, the same with hydrogen and oxygen on the right. So it means I have to still check for the number of this species, both on the left and on the right. So clearly for aluminum it's right, 1 times 2 is 2, 2 times 1 is a 2, 2. For sulfur, I have 1 times 3 is a 3 on the left, and on the right is 3 times 1 times 1 is still a 3 for sulfur. Now we go to hydrogen. Clearly, 1 times 3 is 3, 3 times 2 is 6. Now 2 times 3 is also 6, so 6 plus 6 equals 12. So I have 12 hydrogens on the left, and when we come to the right, it's just a 2, still a 2, it's fine. Now we go to oxygen. 1 times 3 is 3, 3 times 2 is 6. Then 4 times 3 is 12. So 6 plus 12, clearly. So you have 6 there, then you have 12 there. So clearly, I have 18 oxygen on the left side. And on the right, 4 times 3 is 12, times 1 is still 12, then 1 times 1. So that makes it 18. Alright, now so I'm left with the task now of making hydrogen equal, right? So I have 12 hydrogen on the left, and I have 2 on the right. So I have to make them 12, 12. So this would also be 12. So I will stick in a coefficient that would make hydrogen 12 on the right side. And this is where I find hydrogen on the right side. So there's a 2 to start with. So if I stick in 2 times what will give me 12, clearly it's a 6. So I will stick in a 6 as a coefficient there. So 6 times 2 now makes hydrogen 12. But clearly you see that oxygen itself is affected, right? So I will need to go through oxygen once again, both on the... Now on the left it's 18, but now let's see what happens on the right. I have 4 times 3 is 12. 12 times 1 is still 12, so I have a 12 here. The right here I have 1 times 6, that's 6. So clearly 12 plus 6 translates to 18. So the job is done. So I have 2 aluminum on the left and on the right, 3 sulfur on the left and on the right, 12 hydrogen on the left and on the right, and I have 18 oxygen on the left and on the right. Now this is the balanced chemical equation. So this is the balanced chemical equation. Now I need to do one more. Let's say for example we have H3PO4 aqueous decomposes to P2O7 aqueous, then plus H2O liquid. So how do I get this balanced up? Just still the same with the same procedure. So you need to build this for a while, and this while I rub this up and do justice to this in the moment. Alright, so can I rub this off? You need to build this for a while also. Alright. So to get this second equation done, I'll list out the elements and find on the left the solution to this, and also on the right. So clearly I could see hydrogen and oxygen appearing twice on the right. So this should come, hydrogen should come, okay, just immediately before oxygen. So to start with, I have phosphorus. It came out once on the left and on the right. Then I have hydrogen that appeared twice on the right, then followed by oxygen that did the same. So we are now good to go. Now, how many people do you have on the left side? Clearly is 1 times 1, just a 1. Then on the right is 2 times 1, that's the question, that is a 2 for P, phosphorus. Then we'll go to hydrogen. On the left is 3 times 1, is a 3. And on the right, I have 4 times 1 is 4. Then 2 times 1 is 2, so 4 plus the 2, that gives us 6 for hydrogen. Then we'll go to oxygen, that's 4 times 1 is 4 on the left. But on the right, we see it is 7 times 1 is 7, then 1 times 1 is 1. So 7 plus 1, that translates to 8. And clearly the job is, I have to make sure that these numbers are the same, right here. And I can balance the chemical equation. So let's proceed. So I have phosphorus is 1 on the left, 2 on the right. So if I stick in a 2 on the left side, I can make phosphorus a 2. So, and I can stick in the 2 right where I find phosphorus. Right on that substance where you find phosphorus in, right? So clearly, phosphorus is 1 times 2 now. It's a 2 of phosphorus. Now, this 2 also affects hydrogen and alongside oxygen, right? So hydrogen becomes 3 times 2 is 6 now. Then oxygen becomes 4 times 2, that is 8. And then if you go through these numbers, you see I have a 2 for phosphorus on the left and on the right. Hydrogen is 6 the same, both for left and the right, and oxygen is 8, 8. So clearly, this is the balanced chemical equation. So